Now we're going to look at electron arrangement in atoms. We're going to do electron configurations because in most stable atoms, electrons occupy the lowest possible energy orbitals, and this is going to lead us to doing electron configurations for elements. And these are just ways in which electrons can be arranged in various orbitals. Now we're going to follow three rules when we do electron configurations in quantum numbers. The first rule is the Aufbau principle, which basically says electrons occupy orbitals of lowest energy first. Let's see, here's what that means. And I will give you a periodic table that will help explain this as well. But we always start with the lowest possible energy, which is 1s. Once the 1s is filled, we move to the 2s. Once the 2s is filled, we go to the 2p. Then we go to 3s, 3p. Once those are filled, we go to 4s. Then come back to the 3d, then 4p, 5s, 4d, 5p, 6s, 4f, 5d, 6p. And if we fill all those, we move to the 7s, then the 5f, then the 6d. And so basically we fill the 1s first. If that's filled, we move to the 2s. Once you fill that, you go to the 2p and so forth. And you keep going until you have the correct number of electrons for your particular element. Okay, so that's what the Aufbau principle says. We always start with 1s. So a couple questions here. Do all orbitals at energy level 4 have the same energy? Well, here's a 4s, here's a 4p, here's a 4d, here's a 4f. Do they have the same energy? No. Even though they're energy level 4, they do not have the same energy. The lowest energy is way down here, 1s. Highest energy, way up here. Which has higher energy, 4s or 3d? Well, 4s is actually lower than 3d, so the higher energy would actually be 3d, even though it's energy level 3. So, low energy down here at 1s, high energy up here at 6d. Second rule that we're going to follow is the Pauli exclusion principle. And this just simply says an atomic orbital can only describe up to 2 electrons. If you have 2 electrons in the same orbital, they have to have opposite spins. And we're going to get into this in class more when I go through examples. And then the third rule is Hund's rule, which says electrons occupy orbitals of the same energy so that each orbital contains 1 electron with the same spin before pairing occurs. So these are the 3 rules that we're going to follow, and as I go through examples in class, these will begin to make more sense. There are some exceptions to the Aufbau principle, and the exceptions occur because filled energy sublevels are more stable than partially filled, and half-filled subshells are more stable than other configurations. There are 5 exceptions to the Aufbau principle. Here are the 5 exceptions. Cr, Mo, and by the way, these are all transition metals. They're all in the middle of the periodic table. Copper, silver, and gold. Those are the 5 exceptions that I want you to be responsible for. Now in reality, there's more than 5 exceptions, but I'm trying to simplify this for you. I know it probably doesn't sound too simplified right now, but I am trying to simplify this for you. So these are the 5 exceptions, and again, during class we'll go through more examples. And we can also do shorthand notation. Instead of writing the full electron configuration starting with 1s and then going to where we need to stop, we can write the group 8a element in the previous row followed by the rest of the electron configuration. And I will go through these examples in class as well.